A, B, and C are the vertices of triangle ABC. AB is parallel to DF. G is the midpoint of BC. E is the midpoint of AB, and F is the midpoint of AC. So we need to determine the following: the gradient of the line AB. So the gradient is denoted by M, so let's just call it AB. So gradient is just change in y over change in x. So which is just y2 minus y1 over x2 minus x1. So to determine gradient, we need two coordinates along the line. So in this case, for the line AB, we use coordinates B and E. Okay, because gradient along a straight line is just the same. All right. So our x1 will be, and our y1 will be our B coordinate, and our x2, y2 will be our E coordinate. Okay. So now we can solve for the gradient of the line AB. So it's gonna be half minus, then in brackets minus 3 over, then we say 3 over 2 minus, then in brackets minus 2. Okay, so now let's simplify. Get a half, then plus 3, and 3 is just the same as 6 over 2 over 3 over 2 plus 2. 2 is just the same as 4 over 2. Okay, then our gradient AB is gonna be, if we simplify, we get a 7 over 2 all over a 7 over 2 as well. So this will just give us a 1. So our gradient is just equal to 1. So let's determine the coordinates of point A. Where is point A? Here. So determine the coordinates of point A. And the good part is we know that E is a midpoint of AB. So we're going to use this formula of midpoint to calculate the point A. So the formula for determining midpoint is as follows. It requires two points. In this case, it's B and A. Right? So which implies that for those points, one of the coordinates should be our x1, y1, and the other one should be our x2, y2. All right. So then P will be our midpoint E. So let's write what our midpoint is 3 over 2, then 1 over 2. This is our midpoint, which is E. Okay. And to get this midpoint, we use this formula. So we're gonna substitute these values into this formula. All right. So our x1 is -2, and our x2 is A. Then we divide by 2, and then our y1 is 3, then a -3, I mean, then plus B, our y2, then divided by 2. Okay, cool. So now what we're gonna do is this first value is our x value, this is our y value. Same applies, this is our x value, this is our y value. So what this implies is this value should equate to this value, as well as this value should equate to this value, because they are just equal. All right. So we say 3 over 2 is equals to -2 plus A over 2. All right. And we do the same. We say 1 over 2 is equals to -3 plus B over 2. So what this implies is, since the denominators are the same, it applies that numerator should be 4. So we have 3 is equals to -2 plus A, which implies that our A should be equals to 3 plus 2, which is equals to 5. Alright, how about our B? We use the same trick. The denominators are equal, which means the numerators are equal, which is equals to -3 plus B, which implies that B is 1 plus 3, which is equals to 4. So our coordinate A is 5 and 4. So on question 4.3, we need to determine the equation of the line segment DF. Leave your answer in the form y equals to mx plus c. So DF is parallel to AB. So which means they have the same gradient as indicated by this information as well. So to calculate the equation of DF, we need to use this formula, and we just need the gradient and just a single point along that line DF. So we use this point F, which is given. So we have 7 and 1. What about the gradient? What will be the gradient of this equation? Since we said they're parallel, you have the same gradient. The gradient of AB is 1, which means so will our gradient for DF. So now let's solve. So we substitute on y1 with 1 and our gradient, then with x minus our x1 is 7. Okay, so we have y is equals to, multiply with 1, just get x minus 7, then plus 1. So y is equals to mx minus 6, which is exactly in the form y is equals to mx plus c. Okay. So on question 4.4, we need the coordinates of D, which is the midpoint of line BC. So we use this formula to determine it. Alright, so this will be our x1, y1 coordinate. This will be our x2, y2 coordinate. So we just have to substitute correctly and determine this midpoint. Alright, so let's just do likewise. D is equals to, our x1 is -2, our x2 is 9 divided by 2. Then our y1 is -3, then our y2 -2 divided by 2 as well. Right. Let's simplify. We get -2 plus 9, we get 7 over 2. Then here we get a -5 over 2, which is our solution. So we are now on problem 4.5, where we need the length of the segment G to F. Alright, so we'll use this formula. We say root of, in brackets, x subscript 2 minus subscript 1 squared plus in brackets y subscript 2 minus y subscript 1 squared. So modulus of df is just implying that we need the distance from D to F. So this will be our x1, y1 coordinate. This will be our x2, y2 coordinate. So now let's just substitute and find the distance. Alright, so this is 7 minus 7 over 2, then we squared, then plus our y squared, which is 1, minus in brackets minus 5 over 2, and we square everything inside. Alright, now let's simplify. So 7 over 2 is the same as 3,5. So 7 minus 3,5 just give us 3,5, or we can say 7 over 2, and square it, and plus. So minus and minus just leave us with the plus, and 1 is the same as 2 over 2. And 2 plus 5, we can just get a 7 over 2 as well, and then we square it. Alright. So this is just going to give us a root of 7 squared, will just give us a 49 over 4 plus a 49 over 4, which will just give us a root of 49 plus 49, will just get a 98, and it's over 4, which is just equals to 20 root of 24 over 5 if we divide. And if you punch this in your calculator, you get 4,95 is our solution. Okay, so let's move on to question 4.6 and determine the equation of a line that passes through the point C, which is perpendicular to line AC, in the form of y is equal to mx plus c. So let's highlight that line on our diagram. Okay, so to find the equation of this line, we use this formula. So to use this formula, we need two pieces of information. First, we need the gradient as well as a point which is along this line. So we use the point C, which is because it's along this line. So this will be our x1, y1 coordinate. So now we need to be worried about the gradient of this line. So we're given that this line is perpendicular to the line AC. So we use this given information here, that the product of the gradients of perpendicular lines is equals to -1. Okay, now express it as the gradient of the line AC multiplied by the gradient. Let's just call this the gradient of the line through point C. Alright, so their product should give us a -1, which means the gradient of our line should be equals to -1 over the gradient of the line AC. Okay, so first let's determine this gradient of the line AC. Then we'll substitute it and find the gradient through the line through the point C. To calculate the gradient of line AC, we need 2 points along this line. You can use A and C, or F and C, or A and F. Just up to you. So let's just stick with with F and C. All right. And the formula to calculate our gradient of line AC is equals to, we say y2 minus y1 over x2 minus x1. Alright, so we need to determine which is our x1, y1 coordinate as well as our x2, y2 coordinate, and we already determined it. So now let's substitute these values into this equation and solve for the gradient. Alright, so this is equals to our y2 is -2, and our y1 is 1, then our x2 is 9, then our x1 is 7. Okay, so let's simplify. This is -3 over 2. So this is the gradient of our line AC, and we should save this value here. Okay, so now let's find our gradient of line through point C. So this is equals to -1 over, our gradient is -3 over 2, as we already calculated it. Okay, so this negative and this negative cancel out, and this will leave us to the 2 over 3 as the gradient of the line through point C. So let's just write our gradient here is 2 over 3. Now that we have all the pieces, now let's connect them together. So we have y minus our y1 is -2 is equals to the gradient, which is 2 over 3. Then x, our x1 is 9. Okay, so this will give us a +2 is equals to, let's expand the brackets. You have 2x over 3, then minus 18 over 3. Alright, so let's group like terms together. We have y equals to 2x over 3, then minus 6, then plus, now -2, right? So we will end up with 2x over 3 minus 8 is our solution. So let's move on to question 4.7, where we need to find the size of angle of inclination theta, which is between line AC and the x-axis. Alright, so this is the angle which we need to determine. Alright, so we're going to use this formula to solve it. So the formula says theta is equals to arctan or tan inverse of the gradient m. So in this case, the gradient which we are dealing with is the gradient of the line AC. So we're going to say m of AC. Right. But in this case, it's inclined sort of the other way. Right? But it's along the line of the x-axis. Okay, so to correctly apply this formula, first let's try to determine where this equation is coming from. So let's go this side theta, which means this angle here, it will be 180 degrees minus theta. Alright, so 180 degrees minus theta, because angles on a straight line, they add up to 180. Alright, so if we want to find this angle, right, we say let's call this side, this vertical side, change in y, and this other one change in x from this point to here. Alright, if we use trigonometrical ratios of tan, okay, so let's just write tan 180 degrees minus theta. This is equals to trigonometrical ratios of tan says it's this it's the opposite to this angle and adjacent to the angle. So it will be equals to change in y over change in x. And change in y over change in x is gradient. So in this case, since this is along this inclined along this line, in this case that's line AC, so it will be the gradient of line AC. Great. So This implies that we can now re-express this expression. We have tan, right? 180 degrees minus theta is equals to gradient of m of AC. So it implies that 180 degrees minus theta is equals to tan inverse of the gradient on the line AC. So our objective is to find theta, which is the one I highlighted here. So we simply have to make it the same formula. So I'm going to clear some part of the board. Okay, so let's solve for theta. So first let's make it the same formula. So we say 180. Let's move it to the right hand side of the equation. So we say minus tan inverse of the gradient of the line AC is equals to our theta. Alright, now let's determine the gradient of line AC. We saved it here. Okay, so we just have to substitute it back. So we can say theta, or let's just say 180 degrees minus tan inverse of -3/2 is equals to theta. So just punch this value in your calculator. You punch second function tan and then -3/2, and you get a value of 56,31 to 2 decimal places. And if we subtract these two values, we get 123,69 degrees as our value of theta. All right. So this is our solution.